इंडिया में अगले 5 साल में 20 मिलियन नए जॉब्स आने वाले हैं इन द फील्ड ऑफ AI. AI engineers in India make anywhere from 12 to 15 lakh per annum as a fresher. Hi everyone, I'm Ishan Sharma, and if you want to start your journey as an AI engineer, this is the perfect video. So let's break down the world of AI piece by piece, step by step. Make sure that you hit the like button and watch this till the very end. And if you keep watching, I'll share an amazing free resource from HubSpot which will help you in your journey of learning generative AI. Now, if you are getting started in AI, it's very important to take a step back and understand the basics of AI. And artificial intelligence starts with mathematics. You first need to understand the basic math concepts based on which all the AI algorithms are created. So if you are getting started with no experience, it's very important for you to learn the maths. A couple of concepts to master in maths is first going to be linear algebra. Second, you need to learn about matrices and determinants. This is something that you would be using quite a lot when you're dealing with data, when you're dealing with different types of dimensions. And with that, it's also important to learn about calculus and probability. Once you learn differentiation, integration, and the concepts of probability, you are all set, good to go to start your journey in the space of AI. Now, I'm not talking about solving problems and doing that fast like you were doing in 12th. I'm talking about actually having an idea about what differential calculus is, about what does integral calculus look like, what is the meaning of it, understand how they work, how does it operate, what are the different rules you should be aware of. Then learning about probability and the different types of probability. So it's less numerical, it's more having a understanding of these concepts. And for these math concepts, I just love Khan Academy and 3 Blue 1 Brown. These are two platforms on YouTube that you can log on to and learn the basic math concepts. Now, once you understand the math, we can move on to the next step, which is still not AI. We have to take a step back and learn about one basic thing, and that is a programming language. You need to learn one programming language so that you can communicate with your system, so that you can create algorithms in the language that the laptop will understand. And that is Python. Python is the most widely used programming language if you want to create machine learning algorithms and use them. Now, I want you to learn the very basics of Python. Things like data types, understand about conditionals, understand about for loops, understand about basics of creating a function and using it, learn about objects and classes, how to create a class, how to create objects in that class, do all of that. And once you solve some basic questions and have written some programs in Python, you can now move on to the next step, which is the world of data science. I personally learned about Python from this amazing playlist by Tech with Tim. You should totally have a look at that. Or you can also check out this video by Free Code Camp. You've probably heard everyone talk about AI, but you're unsure about how to get started. That's where this amazing resource from HubSpot comes in. It breaks down the complete process for how you can adopt AI into your workflow. The guide starts with defining your business problem, helping you figure out exactly where AI can help you the most. If you're new to AI, the educate and train employee section is super helpful. It shows you exactly what skills you need to learn and how to get started without feeling overwhelmed. Moreover, it gives you actionable steps on how you can develop a project pilot. This means starting with just one AI project to see how it works. It explains how to choose the best processes for testing AI, setting clear goals, and ensuring you have the right data. You even get examples of how AI is helping businesses right now. So if you're a student looking to upskill your knowledge about AI, this playbook gives you the clear roadmap to using AI in 2025. Check out the HubSpot's AI adoption playbook from the link in the description of this video. It's completely free to download, and let's move on to the next topic. Now, data science is the field of understanding data and using it to your advantage using the three most important libraries. The first one is NumPy. NumPy is a great library which has the concept of arrays. I'm not talking about lists in Python. Arrays is different. And this is where the concept of matrices will come in handy. So you learn about NumPy arrays and how to use them, what are the different functions and parameters of it. And once you do that, the next thing to learn is pandas. Pandas is a library of Python which enables you to manipulate data in columns and rows. So if you have a table of data, how do you create operations on it? How do you come up with answers? How do you use it to get some answer out of it? You will learn all of that in pandas. The next step is to actually visualize that data that you've just created. And that you will do with the help of Matplotlib. So once you use any algorithm, once you solve any problem, you want to now visualize the data and show people what you found, the insights. And the best way to do that is with the help of either pie charts or line graphs or bar graphs. And you can do that very easily with the help of Matplotlib. Again, Free Code Camp has a free masterclass on data science. Go check that out. You will learn for free the basics of NumPy, Pandas, and Matplotlib. And once you solve some basic problems using it, once you have a good hang of it, we can now finally move into the world of machine learning. Before this, you can also check out Kaggle. Kaggle has a ton of problems, data sets that you can tinker around with, that you can use to learn and get better at data analysis and data science. Now, it's very important for you to understand this, because even before you create an algorithm to solve a problem, it's very important for you to understand how to have a good data set, data cleaning, getting the right data for your model and training on it. That is very important, and that is what you learn in the space of data science. But once you're done with that, let's move on to the next step, and that is machine learning. Now, machine learning, algorithms, what do these all mean? Let me break it down for you. Machine learning, if you have never understood the meaning of it, it's basically a process in which I have an input, I have an output, and now I have to build a system which can predict the output from the input using any algorithm. I don't know what the algorithm is, that is the black box, but I have to essentially build a model which can provide me a prediction for that. That is the idea of machine learning. And an algorithm is basically a series of steps that you take to arrive at an answer. As a machine learning engineer or an AI engineer, your focus is on creating that algorithm that can best predict the output from the input that you have. Now, inputs can be of two different types. The first input can be a labeled input, labeled data, or it will also be an unlabeled data. For example, let's say you have pictures of cats and dogs, and you've actually mentioned if it is a cat or if it is a dog. That is labeled data because you've labeled and given information about this data. But let's say you have just some random pictures of planes, of cars, of other means of transport, cycles, bikes, but you have not written or mentioned that this is a car, this is a bike. In that case, that's an unlabeled data. Now, we have to approach these problems separately. If you have labeled data, we can use something called as supervised learning. And the other one in which you have unlabeled data, it's called unsupervised learning. And then there's another algorithm that you can use called reinforcement learning, which we'll come to in some time. Now, let's talk about supervised learning. This has a series of algorithms, a series of techniques that you can employ to do two things particularly. Either you can predict a future value for something. Let's say you are living in Bangalore and you have information about rain in Bangalore on every year. So you can create a chart for that, right? You can have x-axis, can have the years, y-axis can have the centimeter rainfall. Now, let's say you're asked to predict what would the rainfall look like for the next 2 years if you have given the last 20 years of rainfall data. Now, this is a regression problem, right? Because in this case, you have to predict something in the future. This is what is regression all about. The next problem is called as a classification problem, in which you have been given a bunch of data, and that is labeled data, and you're asked that if you have a new value, is it going to be a part of team A or team B? You have to classify that information. So is it a cat or is it a dog? Is it an apple or is it an orange? So you have to predict if it is this or that. So underneath of supervised learning, you have various different algorithms that you can use to solve each of these problems. In the case of your regression problems, you have something called as linear regression, creating a line which best fits the data that you have currently and can then give you the answer for the future. Now, what will be the equation of that line? We know that our normal line equation is y equals to mx plus c. So now you have to predict what is m going to be, what is c going to be. And that is what linear regression is all about. As simple as that. Based on the previous data that you have to understand the value of m and c. And then you will have a line which can then predict the future rainfall with a very good probability. Confidence, we call it in the case of machine learning. So any problem which requires you to predict future information, let's say predicting the price of houses in a particular locality, predicting the price of a particular stock, although that is not a good example, but predicting any value in the future based on the previous history that you have for it. That is what is a regression or a prediction algorithm. Next, you have a classification one. In classification, you have various different techniques which you can use depending on what situation you have. Now, whenever you have a binary outcome that you want to classify for, meaning you have two answers, either this or that, either orange or apple, either cat or dog, either plane or car. In those cases, using logistic regression can be a very good option. Logistic regression is essentially a sigmoid function. You can look at this mathematical function, but on the chart, it looks very simple, like this curve. Now, on this curve, everything has one basic line above which everything is true and everything below is false. It has a great deal of use cases in things like fraud detection, email spam detection, even using it for disease detection, and so on and so forth. The underlying concept is to use this curve, which is a sigmoid function, to tell if something is lying above or below and using a 0 or 1 value, true or false value for it. It's great for binary outcomes, and that is all that it is used for. Another model that you can learn about is called K nearest neighbors, KNN. The idea behind KNN is very simple. Let's say you have a lot of points on a graph. You have just a lot of points. Some of those points are blue, some of those points are red. Then you plot one point in anywhere on that chart, and you're asked to tell if this point belongs to the red or the blue group. How would you do that? Now, in this case, if you're using K nearest neighbors, you would basically look at the distance of this particular point from the red ones, from the blue ones, and then you would compare this distance. If it is nearer to the red dots, then it is probably a red dot. If it is nearer to the blue dot, then it will probably be a blue dot. Now, the K is basically the number of points that you want to consider. Let's say you consider 4 points. So in this case, you're basically looking at the nearest 4 points and checking if they are red or they are blue. And the majority will decide the color of this particular dot or the category of this dot. KNN or K nearest neighbors works really well if you are using it for things like recommender systems, plant species detection, and so on and so forth. Whenever you have multiple groups, but it also has its shortcomings. I've just given you one 2D example, but let's say you have a lot of variables, right? It could be a 3D, 7D plane in which you have various different, features, so as to say. In that case, it's very hard for you to tell the distance between few things. So it's only used for more simpler examples. Then you also have something called as support vector machines, SVM. Essentially, support vector machines is another way for you to classify something. And the way it works is that, let's say you have, again, red dots and blue dots, and you plot a line. You look at the nearest 2 dots and you call those support vectors, and you draw something called as a margin between them. And your goal is to optimize this margin in a way that it is able to predict any value in the future. SVM or support vector machines work really well for handwriting recognition or things like text and image classification. Then you have another one called as a decision tree. And decision tree is a very interesting algorithm. Now imagine that I want to check in our India, let's say we have 30 states. I don't know how many we have right now, but if we have 30 states and I want to check if a particular state would be, going for one party or the other, party A or party B, depending on various factors. It could be the education level, their age, their gender, and I want to take these 3 variables and I want to predict if a particular state will vote more for party A or party B. Now, in that case, we would use something called as a decision tree, in which we basically start with one condition. Let's say I say that the education level, if it is less than bachelor's degree, it would be false. If it is more than bachelor's degree, it will be true. And let's say I'm checking people who have education level more than bachelor's degree would be true, and if not, would be false. So let's say if the people who have a bachelor's degree or more education is true, they are mostly voting for party A and the others are voting for party B. Now this is my first layer. Then we can have the second layer underneath each of these, which would be for the next variable. The next variable that I have is age. So let's say I'm saying that, let's say less than 27 would be false, more than 27 would be true. So then I can say that, okay, out of these people, if anyone has an age more than 27, it would be true. So then let's say we found out that people who have age more than 27 and have education more than bachelor's degree voted for party A again, then I will have another decision tree right there. So we are basically using various different conditions, and basis on that we are creating these decision trees. The idea is to use information gain that we have to come up with the last answer that we have at the end. So that if I am presented with, let's say there is one person who has, a PhD, who is from the age of 30, it is a male. Tell me who would this person vote for. Now I can use this decision tree that I have just trained on all this data, and I can predict where would they normally vote, if they would vote for party A or party B. It might be confusing, but the basic idea is to start with one condition and have different layers on different conditions and having a true or false statement, and then reasoning through more that, and then arriving at the last leaf, which is your actual answer. Now, decision trees is not just great for politics, it's also great when you're talking about things like risk assessment. So if you want to give someone a loan or not, or medical diagnosis, if this person has this particular medical problem or not. So you can detect that because you have various different variables, and basis on that you arrive at a conclusion. The next, another very interesting model is called as random forest, which is nothing but an ensemble of various different decision trees. So model ensembling is a process in which you use various different models. You predict the value for something or classify something, and then you take the majority answer as the actual answer. So in case of random forest, you have various different decision trees, all having various different answers, and then you pick the majority answer. The reason it is called random is because each of these decision trees are different, because the training data that we send to them is different. So instead of sending all of the training data, I am randomly picking numbers from my data set, and then I'm feeding it to different decision trees and coming up with different outcomes. And then I'm taking the majority of all of their decisions. That is basically what a random forest looks like. Now we have another model called as naive Bayes. Naive Bayes is a very interesting model. It all comes down to Bayesian probability. Again, I told you should learn about probability in maths. This will be helpful here. Bayesian probability, basically, let's say I want to predict if one fruit is a orange or an apple, and I'm judging it on two basic variables. Its color and its taste. Then I say probability of this fruit to be apple, considering its color is red. I will get a probability. This is conditional probability. The next, I take probability of this fruit to be an apple, considering its taste is sweet, and I get a probability. Then I take another probability for this fruit to be orange, considering its taste is sour, considering its taste is sweet. Then I take one more probability for its color to be orange or its color to be red. Then I multiply these probabilities, and that is how I'm able to arrive at naive Bayes probability. And naive Bayes can be used for a lot of things which involve spam filtering or sentiment analysis. Now we have another model called as neural network, which we will come to in some time. But now let's go back to the next topic, which is called as unsupervised learning. So in this case, you do not have information about what this data is about. So you just have random data, and you have to predict the differences between them. So you have to categorize between both of them. So it's always going to be a classification problem. And there's a lot of different models in this which are more complex than this video. But I want to keep it short, so we will talk about k-means clustering. Now, k-means clustering is very similar to k-nearest neighbors, but in this case, imagine a lot of different dots of different colors. Let's say we have 3 different colors of dots on a x and y axis. You are basically asked to classify all of these different categories of dots, and you would do that using k-means clustering, in which k is going to be a number. Let's say if you choose 2, then you check if this model is fitting the data or not. So basically, you would only be able to have 2 different categories. You would realize that with 2 categories, the answer is not actually as optimized as if you use k equals to 3. And in 3, you can have 3 distinct groups that you have created for yourself. And that is better because you're getting answers that are more relevant. And that is basically the idea of k-means clustering. There is a formula for that you can check, but this is the basic understanding of it. Now, k-means clustering is great for segmenting users based on their purchasing behavior. So you can have different groups of people. You don't know exactly who they are. It's just unlabeled data. But depending on their purchasing behaviors, you can categorize them as category 1, 2, and 3. And that is the idea of K-means clustering. Now, another part of machine learning, which we are yet to talk about, is reinforcement learning. Reinforcement learning is this very interesting, the most fascinating method of all, in which you have an autonomous agent. The agent is in an environment where it can make actions of its own. And by trial and error, it has to figure out a way to maximize its reward. So let's say that you have your hero and then you have a orb, or you have its food over here. Now, if this hero moves here near to the orb, it should be rewarded with some number. If it moves on the opposite direction, it should be penalized for it, so that it learns that for you to win the game, it needs to move in this direction. And that is the idea of reinforcement learning. We are teaching the agent to increase and maximize the score by coming closer to the goal. So it is basically learning, and whenever it does something right, we reward it for it, right? And it is asked to maximize the rewards. And by doing so, it is able to learn how to perform a certain activity. Now, this is very fascinating. It has a lot of use cases in things like self-driving vehicles, in robotics, in teaching AI to play games, in finance, in recommendation systems. Now, you can learn all of this, supervised learning, unsupervised learning, even reinforcement learning, by this excellent CS50 course on AI. So go on it, start learning from its individual lectures. It's going to be like 2 hours each, and you learn all of the information in depth. You can also check out some amazing videos by Free Code Camp if you want to check that out, and just start learning about it. Start taking up some problems. The most important problems are into classification. That could be image classification. It could also be predicting future prices of things, which is a linear regression problem. But just try your hand at solving various different problems. Try to approach a question with different algorithms. Try maybe k nearest neighbors. Try decision trees. And then you will understand which is better for what scenario. You know that if you only have 2 outcomes, maybe logistic regression is better. Or maybe for certain cases, using support vector machines might be better. So learn how to use all of these tools in your arsenal that you have right now. But now let's talk about the most fascinating of all of these, neural networks. Neural networks is a part of supervised machine learning, in which it is basically creating a structure similar to that of your brain, in which you have various different layers. Each layer is made up of different nodes, and you have an input layer and you have an output layer, and in the middle you have something called as a hidden layer. Now, hidden layer is where all the magic happens, which you don't even know or get to see. They call it the black box for a reason, because you don't even know what's happening, or you don't need to know what is happening inside. So think of neural network as a way for predicting handwriting, for example, right? So let's say you have a 64 into 64 picture of different letters that you've written, or numbers that you've written, 1 to 9 or 0 to 9. Now, your model, your neural network needs to predict if this new picture is 1 or 2 or 3, or give a probability for each. The way it works is, it is going to be 64 into 64 nodes in the input layer, and each pixel is going to have a value between 0 to 1, and that is the value of that particular node. Now, from one layer to another, there will be some activation function in which it will have some weight and it will have some bias. So it's called as W1. Think of it like every signal that goes from one node to the next node of a hidden layer, it's going to have some function. It could be Y1 equals to W1 X1 plus B1. And you have similarly for every connection that you make from one node of an input layer to the next node of the hidden layer. And that is essentially what creates the learning in a neural network. It starts with being completely random. So every node will store some value, and at the end, the output layer will have one number, which will be the probability for this to be either 0 or 1 or 2 or 3 or 4. And then we pick the highest probability number. Now, the way that this neural network becomes better is with the help of this thing called as back propagation. Now, in back propagation, you are basically creating a function in which you are telling the model the right answer after it has made the choice. So let's say it starts with being completely random and saying that this new picture is actually going to be 0. Then you give it the actual information, which is that this number is actually 1. Now it will take that information and back propagate it in the model to improve it, to make it better. And when you do this over and over and over again, by back propagation, you're able to adjust the weights and biases of every function that you have between one node to another in a layer, and you're able to arrive with the right answer, which is the highest probability for one picture to be that number, which is actually correct. That is what a neural network is all about. You don't need to know what is happening in the middle, right? When you are creating a program, you don't have to worry about what is happening in the middle. You just need to know how a neural network really works. In that hidden layer, it could be one layer, it could be two layers. Now, these layers will depend on the number of features that you have. So let's say every digit could have this one small line, it could have one long line, it could also have one curve. So for each of these, you would have various different layers in the hidden layer itself. And each layer stands for the probability of this thing to have this particular feature, of this image to have this particular feature. And that is how you are able to arrive at the right number. So the more layers you have in the hidden layer, the answer might be better. But if you have too many, there is a concept of overfitting that you have to learn about. So the idea is, if you try too hard, the answer comes out to be gibberish value. So you do not want that. So that is the idea of neural networks. Most neural networks, the most normal one that you will see is called as a feed forward neural network, in which you're basically taking information. In this case, it is the value of 0 to 1 of every pixel from one node to another, and it is going from one layer to another, to the third, to the fourth, to the output layer. This is called as a feed forward neural network. Neural networks are great for everything about image classification, speech recognition, data generation, and it is able to do a lot of these tasks in the best way possible. Now, once you learn about the basics of neural networks, you can go into more depth and learn about convolutional neural networks and recurrent neural networks. Convolutional neural networks works on the concept of convolution, and it is great for image classification. Recurrent neural networks works great for natural language processing, NLP, and it is great for things like language translation, language models if you want to build. Now that we are talking about language models, let's finally go into the world of generative AI. We have two different things to talk about. One is a diffusion model, and the second one is called as a large language model. What's a large language model? It's basically a transformer. Chat GPT is basically chat generative pre-trained transformer. What is a transformer? Let's understand that. Transformer is another neural network which takes in a lot of data of text. It takes all the input that you're giving, and basis on that input, it predicts the next word based on all the information that it has. That is basically what a transformer does in a large language model. Now, inside every transformer, you have something called as a parameter. Think of parameter like a node that you have in a neural network. But in this case, this parameter can adjust itself depending on what value you have at the end. Now, Google published a study for transformers in 2017, which was called as BERT, B-E-R-T. And the idea for it was basically that they would be turning every word into a number value, which would then be fed into these transformers parallelly. And it introduced this concept of attention. And if you want to improve a large language model, they do something called as RLHF, reinforcement learning by human feedback. So there's a human which is actually telling it that, this output is better, this output is better, and it's getting feedback. And then it is feeding that feedback to this transformer in reinforcement learning. Basically, it's telling that, okay, this is better. So the agent is learning what is better, and it will do more of that. So that is basically how it works. Now you generate a concept of randomness. See, if you ask one question to ChatGPT, every time you ask it, the answer would be slightly different. Why? Because it has a concept of randomness. It's not always picking the number with the highest probability. It is sometimes picking the second or the third or then the first word which is coming next in the sequence in this language model. And that is the basic idea of large language models and how they operate. 3 Blue 1 Brown has an exceptional video which goes into much more depth in the world of large language model. Go watch that. You will learn the idea of creating a transformer, of BERT, of attention, of how all of this basically works, and you will become better at understanding LLMs. And if you want to start building LLM based applications of your own, check out Andre Karpathy's YouTube channel. Now he has a series of videos which go into depth talking more about how large language models work, and then how can you build something on top of a large language model. How can you build apps which use the underlying ChatGPT model that is pre-trained, right? So that is basically a great starting point for you to learn more and get better at creating these LM based apps. And that is essentially all you need to know if you want to start your journey of learning AI and becoming an AI engineer in 2025. How was this video? Let me know below in the comment sections. I think I started learning AI back in 2020 and it was a fascinating field for me, and I just wanted to share all the learnings that I have with you in this video. If you have any questions, let me know below in the comment section. If you want to learn more about LLMs and generative AI, check out HubSpot's link in the description and get started with that as well. The description will also have more resources, free courses that you can do to learn more about the different concepts that I've just talked about, be it machine learning, supervised, unsupervised, reinforcement learning, neural networks, transformers, and more in depth. I'll see you in the next one. Bye-bye.